Coming up on Destination Tomorrow, we'll travel to NASA Johnson Space Center to find out why radiation will be one of our major challenges as we prepare for missions to the Moon and to Mars. We'll also travel to Brookhaven National Laboratory to examine how researchers are studying the effects of radiation on human tissue. All this and more next on Destination Tomorrow.
Hello everyone, I'm Steele McGonigal.
And I'm Kara O'Brien. Welcome to this edition of Destination Tomorrow.
On this episode, we'll be focusing on how radiation will affect our efforts to reach destinations like the Moon and Mars.
In recent years, NASA researchers have been striving to meet the goal of sending astronaut crews to the Moon, Mars, and beyond. Although there are numerous technological and logistical hurdles to get over, one of the most daunting challenges facing us will be protecting astronauts from harmful radiation. Here on Earth and in low Earth orbit, radiation risks are somewhat mitigated due to the protection provided by our thick atmosphere and our magnetosphere. But outside the protection of Earth, the radiation in space could prove deadly if humans are not properly protected.
Even though radiation studies have been going on for years, new questions are being asked in preparation for extended stays in space. Some of the key questions NASA researchers must address include: how can we assure survival and health of humans traveling far from Earth? What technology must we create to enable explorers to go beyond where we've been? And what new opportunities can research bring to enrich the lives of everyone back here on Earth?
To help answer these questions, we'll travel to some of the facilities that are allowing us to better understand radiation and the dangers astronauts may face. Up first, correspondent Tonya St. Romain spoke with Mark Weiland of the Space Radiation Analysis Group at NASA Johnson Space Center. This group is working hard to monitor and protect our crews from this dangerous radiation. Here's Tonya to explain.
Living and working outside of Earth's atmosphere is a very dangerous proposition. Extreme temperatures, lack of oxygen, and hosts of other risks make space a very hostile environment for humans. But one of the least talked about and most dangerous risks associated with spaceflight is radiation exposure. When astronauts travel outside of Earth's atmosphere, they're routinely exposed to much higher levels of radiation than are typically encountered back here on Earth. For this reason, the Space Radiation Analysis Group, or SRAG, is working to develop tools that will monitor radiation events caused by the sun and other radiation-producing sources. These tools will be used to help us better understand how to keep our crews safe from radiation exposure when traveling outside the Earth's atmosphere. I spoke with Mark Weiland at NASA Johnson Space Center to find out more.
Our team here at SRAG is a great group of people who's charged with keeping the radiation as low as possible to the astronauts. And we do this with monitoring, with shielding analyses of new vehicles, and with real-time support and mission control.
How is radiation measured in space?
We have to use different kinds of monitoring techniques than you use on the ground. If you work in a hospital or a nuclear power plant, they have radiation instrumentation which measures very different types of radiation than we're concerned about in space. So the instruments we use are very different. We also have monitors on unmanned vehicles. The GOES spacecraft, which watches weather on Earth, also has radiation instruments on it that we use. And there's other instruments that are closer to the sun that we look at. We have to measure this radiation because it's very damaging biologically to the crew. We know this from research that shows space radiation can be more harmful to people than radiation here on Earth. And it's also a legal requirement. Astronauts are classified as radiation workers, and so we have to monitor their exposures. We also, by doing this, we know when they approach administrative limits and legal limits, and so that we can take action to prevent them from getting there.
Where does radiation in space come from?
Actually, it comes in 3 different places when we're in low Earth orbit, like on Space Shuttle or Space Station. We have radiation from our trapped radiation belts, the Van Allen belts. We have radiation that comes from outside our solar system called galactic cosmic radiation. We also have radiation that comes from the sun during big solar particle events. Now, the sun has an 11-year cycle that goes from very minimum amounts of activity to very maximum amounts of activity. And during the maximum amounts of activity, we have lots of solar particle events and solar flares, and we can get radiation from those events. Now, when we're going back to the moon and we're outside of the Earth's protected belts, it's going to be much more dangerous for the crews. We can cause acute effects. The crew can get sick very rapidly, unlike they can on Space Station or Space Shuttle.
After about a half-century of human spaceflight, radiation detection and predicting space weather events is still not an exact science. Unfortunately, we cannot accurately determine when large particle ejections, called coronal mass ejections, or CMEs, will occur. A large CME can contain billions of tons of matter that can be accelerated to several million miles per hour. At these speeds, particles can reach Earth in a very short period of time. When the particles reach us, they collide with our magnetosphere and create auroras over the polar regions. Although beautiful to watch, the events which lead to this phenomenon can be very damaging and dangerous to astronauts outside the protection of the magnetosphere. In fact, between the Apollo 16 and Apollo 17 moon missions, a large solar particle event occurred. If astronauts had been in space during the event, the doses of radiation they would have been exposed to could have produced severe health effects within a short time. This is one of the main reasons better radiation prediction and monitoring are a focus of study.
How much time do you have to predict solar flares?
Well, it's actually very difficult to predict space weather. Just as we have a very hard time predicting hurricanes and tornadoes here on Earth, it's very difficult to predict when a solar flare is going to happen. A lot of solar physicists around the world are working on that problem, but right now we don't take action with the crew until we measure an increase in radiation. We are looking at trying to predict when there's an all-clear period. That'll allow us perhaps to do an EVA on the surface of the moon when we know there's a 90% chance we won't have a bad solar flare within the next 2 days. Yeah, the sun has an 11-year cycle, and every 11 years it goes from solar minimum, 5.5 years later to solar maximum, and then back to solar minimum again. During solar minimum, there are very few sunspots, if any, and thus no solar flares. All the solar flares and solar particle events come out of the sunspots. During solar maximum, we have a lot of activity going on with the sun, and we have a lot of solar particle events. So during solar maximum, we're very active in mission control, trying to keep the crew from getting too much radiation from those events.
Is there a difference in the sources of radiation in space?
There actually is. From solar particle events, we can protect the crew from that type of radiation. From the galactic cosmic radiation, it's very heavy ions, high energy types of particles that we cannot shield against. It would take too much shielding and it's cost prohibitive to put that much mass up there. And the reason we try to keep the crew's dose as low as reasonably achievable is because any increase in dose is directly proportional to an increase in the probability that they'll get a fatal cancer. And unlike many of the risks that astronauts are exposed to, and there are many, radiation is one of the few risks that they will carry with them the rest of their life.
Do you think our predictive models will change dramatically for future missions?
Okay, actually, I think they will get better. I believe that all the science that's being done by all the solar physicists and the space physicists is going to lead to better predictive models. They're doing a lot of great work. They are launching a lot of new missions, and those missions are there to explicitly study the types of physics that will lead to these better models. As we prepare to go back to the moon and Mars, our team here at SRAG is extremely excited to be a part of that effort of keeping astronauts safe. For me and my team to be standing over in mission control when we step foot on the moon again would be one of the greatest achievements of my lifetime.
Space radiation is not typically harmful to us on Earth because the Earth's magnetic field extends thousands of miles out into space, helping shield us from the dangerous particles. Up next, we find out how radiation may affect astronauts on longer duration missions. But first, did you know that some astronauts from the Apollo mission through today have reported actually seeing radiation as flashes in their eyes? The flash the astronauts experience is space radiation zipping through their eyes like subatomic bullets. When the radiation strikes the retina, it triggers a false signal that the brain interprets as a flash of light. This is problematic because this radiation kills brain cells and also can trigger long-term problems such as cataracts, which is a clouding of the lens that focuses light on the retina. Research is now underway to help develop probes that can detect signs of cataracts in humans years before they become visible. Eventually, astronauts might carry such a probe with them on space missions, checking their eyes as they go.
For many years, NASA has been sending robotic spacecraft to faraway planets like Mars. Some of these missions have included instruments that have given us a basic understanding of the types of radiation we can expect outside the Earth orbit. Even with this knowledge, there is still much to be learned about how the radiation in deep space will affect our astronaut crews. To help increase our knowledge base, a unique facility called the NASA Space Radiation Laboratory is testing living cells with the types of radiation found in space. Our Johnny Alonso traveled to the Brookhaven National Laboratory in Long Island, New York to find out more.
Radiation exposure is a very real risk for astronauts.